Now that we've got a few textures created, I'm eager to begin developing the materials. But materials need lights, and so first I need to establish a working light setup that will foster an adequate environment for us to judge our materials. And I'm looking for a few things when it comes to this working light setup. Number one, I need variety. I don't want to depend on only one light setup. That doesn't produce a trustworthy material. But if I test it from multiple light scenarios, it means the material is much more robust and much more trustworthy. Number two, I want to make sure that it's simple to set up, which means we pretty much eliminate using lamp objects. It would be overly complex to have multiple light setups using multiple types of lamps, and that's not the simplicity we need at this stage of the process. And then third, I want to establish a camera with the ability to rotate and capture certain angles that can be re-rendered over and over for the sake of comparison. And so that's going to be our goal for this lesson. Now, first I'm going to switch to the shading workspace because that provides a good user interface to develop materials. And Blender has a built-in working light setup that you may already know about. And when we switch over to the shading workspace, we have the material preview mode enabled. Now our head is pure black, so if I, in the shader editor down here, hit the period key, we are sourcing something that's just pure black, the ambient occlusion. So let's shift control click on the principled BSDF to go back to a default material state. And then I need to clean up a few things like turn off the eyes open and mouth closed shape key. I need to re-enable multi-res in viewport and in the render. And now we're in kind of the clay render mode, which is a neutral type render, great for establishing lighting. And so the material preview is a built-in working light environment, which offers the convenient ability to switch light scenarios with this preset list. And this is the kind of functionality I want, but one that works with true rendering. So this is dependent on the viewport. And also Material Preview specifically uses the Eevee render engine, which we won't be relying on. This kind of rendering is way beyond Eevee's capabilities, at least to get the most realistic result. So we can switch over to the rendered view, which uses the render engine we establish in our render properties. So we're using cycles, and I'm also using GPU compute, taking advantage of my graphics card. You can use CPU, that's fine. It'll just be a little bit slower. But by default, if we look at our options in the render viewport mode, it's expecting us to create a scene world. If we disable that, we get access to those pre-built environments for use in cycles, same as Eevee. And so this is great for viewport interaction. As we change material settings, we will see that update in the viewport. That's great. On the fly, we can switch to a different lighting setup, judge our material, and this is the ideal working light setup. However, we cannot render this. This is only in the viewport. So if I go to render image, we will not see what's in the viewport. And we're going to need to do that because we're rendering with millions and millions of polygons. Eventually, we're going to have hair, refractive material, subsurface scattering in the skin. A lot of complexity, too much to maintain a quick viewport. And so I want to show you how we can use these environment textures and plug them into our scene world so we can render what we see in the viewport. And Blender comes with these HDRI images built into the program directory. So I'm going to go find that. I am on Windows. I recently transitioned over from Linux. That's a long story, not for this course. But I am putting my Blender installs, which I do through the .zip extraction, and I put them in the applications folder, in I guess my Windows home folder basically. Blender, and then from here, 2.93 is what we're using. Go to the 2.93 folder. We're looking for data files and studio lights and world. All right, here we can find the EXRs. Oh, so they're not HDRIs. I don't want to go down this rabbit hole either, but basically .exr and .hdri are image formats which include a much more dynamic range of pixel data, which is necessary to create lighting effects from an image. JPEGs and PNGs have a much lower compressed range, and so they can't work adequately for this. But anytime you're looking for light-worthy environment maps, make sure it's an HDRI or an EXR. In this case, they're EXRs. And if I switch to the World tab and then hit the period key, if that doesn't work for you, make sure your nodes are selected by hitting A and then period key. And then I need to get this EXR over into the shader editor. You can click and drag. Sunrise EXR is the one we're using in the viewport. I'm trying to make this world match the viewport. Unfortunately, it comes in as an image texture, and what we actually need is an environment texture. Okay, that's where we get the equirectangular mapping, which is important. So now that I've got the image brought in, I can simply select that within the environment texture node. And there it is, sunrise.exr. We can get rid of that. This will plug into our background. And then when I re-enable scene world, we see the exact same thing. All right, so we have perfect consistency between viewport and our render. So the only thing missing is a camera. So let's add one. Shift A in the 3D view, we'll go down to camera, and we'll switch to solid viewport shading. And I'm gonna hit Alt-G, Alt-R to put the camera back at the world origin. I'm gonna move the camera forward in Y, and then RX, let's see, not using the 3D cursor, using the median point, RX 90. All right, I want my camera to be perfectly aligned in the Y-axis and then rotated to face our portrait. 0 on the number pad lets us look through the camera. And with the camera selected, I can hit G, Z and move it up. Okay, now by default, Blender is using 1080p resolution, which is a wide frame. And I recommend turning this to 1080 by 1080. That way we don't have all this wasted space on the side. So we've got a square resolution, great for testing. And then I do like to change the focal length of the default camera. If we go to the camera data, the default focal length is 50 millimeters. Now this is valid for a portrait, but I like a bit higher value. So if you're curious, we can go over to Google and type best lens for portraits. Let's see what photographers use. So let's take a look at this. The best lens article here in 2021. Our pick is the 85 millimeter lens right now. Okay, so just a little bit of research will show us that number one is this Canon 85 millimeter. That's all I'm interested in, is the 85 millimeter value. See what the next one is, another 85 millimeter, another 85 millimeter. Okay, are all these 85 millimeters? Usually there's a range. Yeah, this must be the 85 millimeter website. Let's try a different one. Okay, number one is still 85 millimeter. I am going to go with 85 millimeter, by the way, but there should be a range. Okay, here's a 55 millimeter in number 2, another 85, a 50 millimeter. So it is valid for the 50 millimeter range, but there is a spectrum with which we can choose from. And based on this list, and in my experience, anywhere between 50 and even 135, like this one's 135 millimeters. So anywhere between that range should be fine for a portrait. I'm going to go with 85 because I just think the face looks a little more proportional here. Zoom out so that we can like focus on the head. And yeah, I think that's going to work out great. The final component I want to add is a way to easily rotate the camera repeatedly. And I'm going to do this with a empty. So Shift C to return our cursor to the world origin. Shift A and add an empty cube empty. I'm going to rename this in the outliner to cam_CTRL, camera control. I'm going to parent our camera to this empty, Control P object. And now go back to 0 on the number pad to look through our camera. And if I rotate this control, we can easily turntable around our model, which I will want to do at various times in various lighting conditions. And in fact, I like to even set keyframes. So if we add another window in here and change it to the timeline, let's say frame 1 is straight ahead. So insert rotational keyframe here. Hit the right arrow to go to frame 2. Rotate around. Let's look at a 3/4 view. Insert rotation. Next frame with the right arrow key. Let's do a side view. Insert rotation. And now I've got 3 frames that I can easily render and compare incrementally along the way. And I cannot understate the importance of the comparison. I want to be able to switch between renders quickly to judge the various modifications we're going to make to our materials. And at this point, we're set up pretty well to begin developing the material. The only thing that's bothering me right now is my outliner is a mess. And once I reach the rendering stage, I want to quickly be able to turn off accessories, for example, the hoodie and the glasses, just turn them off in the render. And right now it's disorganized and I can't do that easily. So let's take a moment to just develop this a little bit better. I'm going to create one collection, or rename the original collection to be bust. All right, this will include everything to do with the character itself, including clothes. So let's add a new material in there. We'll call it head. And then another one we'll call clothes. And in the clothes group, let's add the hoodie. And let's see, where are my glasses? I must not have named my glasses. Okay, yeah, I never did. So let's call those glasses. Put that in the clothes group as well. Collection. And then retopo is the name of my head mesh. So let's call that properly. Move that to the head collection. And then we don't need this hoodie reference anymore. Let's delete that. The eyes need to go into the head collection. The torso collider we don't need anymore. And then the hair proxies, I don't think we need that anymore either. So let's get rid of that. Delete the hierarchy, so it deletes everything inside the collection. And at this point, we are organized and ready to begin rendering our material tests.